What are black holes?
Black holes are actually stars that have become so heavy that anything that gets too close will fall directly into its core, including light. Bit greedy.
Where do black holes come from?
In the core of a star, hydrogen atoms are crushed together to form helium atoms, which produces a lot of energy. This energy, in the form of radiation, pushes against the star's gravity, creating a delicate balance between the two forces. For stars with way more mass than our Sun, the heat and pressure at the core allow them to fuse heavier and heavier elements until they reach iron. Now, unlike all of the elements that came before, the fusion process that produces iron doesn't produce any energy. The more iron produced in the core, the less radiation given off, and that balance becomes broken and the core collapses in on itself. Eventually, the core will become so dense that it will explode in a supernova, spreading all of the heavier elements into the universe. This will either create a neutron star, or if the star was heavy enough to begin with, a black hole. Black holes have two main parts. In fact, when you look at a black hole, the bit you're seeing is the event horizon, the point of no return.
What is the event horizon?
The event horizon is the last point in space at which light can escape the black hole. Anything that travels beyond that needs to be moving faster than the speed of light to escape, which is unfortunately impossible. Thanks, Einstein. So all we see is a black sphere reflecting nothing. If the event horizon is the black part, then the whole part is known as the singularity.
What is the singularity?
Well, since you have to travel faster than the speed of light to escape the event horizon, which yes, we're very aware is impossible, thank you, we don't actually know what the singularity is, though there are some theories. A singularity may be infinitely dense, meaning all of its mass is concentrated into a single point in space with no surface or volume. Or something completely different.
What happens when you cross the event horizon?
There's only one guarantee when you cross the event horizon, and that is that you're heading straight towards the singularity. For now, we can narrow down the possibilities of what happens within to two options. You either die quickly, or you die really quickly. For someone on the outside looking in, whoever is falling into the black hole would appear to slow down and then eventually appear to freeze on the surface before disappearing. For the person falling into the black hole, they would watch time fly by in front of them before undergoing spaghettification, which, yes, is the best word of all time. This is where the gravity becomes so strong that it pulls their cells apart, leaving them as one stream of one-atom thick plasma. Alternatively, one might cross the event horizon and then be immediately incinerated. Another theory is that information completely breaks down. Information in this case being what defines a heap of atoms as a lemon. Add some more atoms and a little bit more bitterness, and you have a wannabe Viking space YouTuber. Within the singularity, this information could be meaningless, and a human could be indiscernible from a banana.
Do black holes suck stuff up like a vacuum cleaner?
Fortunately not. If you replaced our sun with a black hole of similar mass, nothing would really change. Except that we'd all freeze to death.
Do black holes die?
Yep. Even though black holes are immensely powerful, they will eventually evaporate away through a process called Hawking radiation. To understand Hawking radiation, we need to look at empty space, which is not actually empty at all, but full of virtual particles that pop into existence and then annihilate each other immediately. When this happens at the event horizon, one of the particles in a pair will fall into the black hole, while the other is free to roam the cosmos as a real particle. This means that the black hole is losing energy, and it happens very slowly at first, but the smaller the black hole gets, it gets faster and faster and radiates more and more energy. In the last second of its life, a black hole gives off more energy than 1 billion atomic bombs going off at once. But like I said, this happens incredibly slowly. The biggest black holes that we know about might even take up to a Google years to die out.
How do black holes affect the fabric of space-time?
Because of the enormous mass that black holes have, it curves space-time in an enormous way. If you imagine a disk of dust orbiting around a black hole, and imagine that you're looking at that disk straight on so that you can see the edge of it, you would actually be able to see the back of that disk at the very top and at the bottom of the black hole. This was exactly what we saw in the very first photograph taken of a black hole in April this year, and it's very similar to an image taken out of Interstellar. Believe it or not, we are actually orbiting a supermassive black hole at the centre of our galaxy right now. But don't worry, we're not going to be getting sucked into it anytime soon. Ow! Ow!